All right, lesson 9a, incomplete dominance. So the key with incomplete dominance problems, which is outlined here, is that when you have a heterozygous individual, neither allele is going to be dominant over the other allele. And so the result is that those two alleles will mix and they produce a third phenotype. And you'll see that if you watch this Amoeba Sister video, you'll see that when they talk about flower color. So you'll have red and white flowers, neither is dominant over the other. So when you have a heterozygous individual who has a red and white allele, the red and white mix to produce pink, or your third phenotype. So you can read through some of the real life examples here. I'm going to take you through the first sample problem that you'll find in this lesson. So the problem says, what are the phenotypes of a cross between a curly-haired woman and a straight-haired man? So as always, your first step is to write the genotypes of the parents. Before you do that, I find it helpful to write out the 3 different genotypes that you can possibly have. So for someone that has curly hair, so we're going to use a capital H to represent the gene for hair, and we'll use the superscript to represent the allele. So the allele for curly hair will be represented by the letter C. Okay, and so to have curly hair, you would need 2 copies of that allele. So that would be the genotype of a curly-haired individual. For straight hair, so again, we're still looking at hair, we'll use an S to represent that allele. And if you have a heterozygous individual with a copy of the straight allele and the curly allele, those 2 will mix. And if you know anything about hair, curly hair and straight hair will mix to produce wavy hair. So that's probably makes it a bit more helpful when you're going through before you actually attempt the problem, define each variable, each genotype. So let's start off with the woman. She has curly hair, so we can just write in the genotype for that, HC, HC, and the straight-haired man. So HS, HS. I like to use lowercase letters here because they are incomplete dominance. So it just, you don't have to, it just indicates that one's not dominant over the other. All right, so your second step is to set up your Punnett square. I'll zoom in here. Same thing you've always been doing before, 1 parent across the top, 1 parent across the side. And when you mix these, you should find that all 4 squares would have the exact genotype, HS, HC. Okay, and then your last step, write out your genotypic and phenotypic frequencies. Again, for this problem, there only was 1 genotype, so 4 to 4 or 100%. And then for your phenotypes, tell me what that code for is, what that codes for. So again, we have 1 copy of each allele, straight and curly. That will mix to produce the wavy phenotype. So 100% chance of having a child that would have wavy hair in those cases there. Okay, I hope that helps.